Hello there, my name is Marfa and I will be presenting on production of powdered milk on behalf of Group 31. The members of this group are Asante Abra Joycelyn, Sefa Mafadia and Kweku Abusechi. So in this PowerPoint presentation, we shall be introducing the concept of powdered milk production. Then we shall look at the visual process flow diagram. And finally, we shall look at the computer hardware needs as well as the software and computer network connectivity needs. One of the biggest benefits of powdered milk is its long shelf life. Unlike fresh milk, which has a limited shelf life, powdered milk can be stored for months or even years without spoiling. This makes it a convenient option for people who want to stock up on nutritious food without worrying about it going bad. One of the biggest benefits of powdered milk is its long shelf life. Unlike fresh milk, which has a limited shelf life, powdered milk can be stored for months or even years without spoiling. This makes it a convenient option for people who want to stock up on nutritious food without worrying about it going bad. Our powdered milk plant is designed to produce high quality powdered milk that meets the needs of customers. We are talking infant formula manufacturers, food manufacturers, emergency relief organizations, and consumers who just want a convenient and nutritious dairy product. With our state of the art equipment and rigorous quality control processes, we can ensure that our powdered milk is safe, nutritious, and delicious. So, we're going ahead to look at the visual process flow diagram. The production of powdered milk begins with the collection of fresh milk from dairy farms. Once collected, the milk is transported and stored in large chilled storage tanks to preserve its quality and prevent microbial growth. This storage step is to maintain the milk's freshness before it undergoes processing. The next step is standardization, where the milk's fat content is adjusted to meet specific product requirements. This ensures consistency in taste and nutritional value for every batch of powdered milk produced. Following this, the milk undergoes pasteurization, a critical step in which it is heated, typically around 72 degrees Celsius, for 15 seconds. Pasteurization kills harmful microorganisms and deactivates enzymes that could cause spoilage, thus ensuring the milk is safe for consumption and has an extended shelf life. After pasteurization, the milk is directed to an evaporation unit where approximately 60% of its water content is removed. This is done using a vacuum evaporator, which allows water to evaporate at lower temperatures, thereby protecting the milk's nutritional content. The resulting product is a thick, concentrated milk that is easier and more energy efficient to dry. This leads to the core stage of the process, which is spray drying. In this stage, the concentration of the milk is sprayed into a large drying chamber filled with hot air, typically around 150 to 200 degrees Celsius. The fine droplets of milk rapidly lose moisture as they fall through the chamber, transforming into a dry powder almost instantly. This method is efficient and helps preserve the milk's nutritional components while converting it into a fine dry form. Finally, the powdered milk passes through a cooling stage to bring its temperature down and avoid the formation of lumps or degradation due to residual heat. Once cooled, the milk powder is packaged in airtight containers or sachets, protecting it from moisture and contaminants, thus ensuring a long shelf life without refrigeration. The final product is a lightweight, easy to store, and highly stable milk powder that can be transported over long distances and reconstituted with water for use in various applications, including infant formula, bakery goods, confectioneries, and emergency food supplies. Let's go ahead to look at the final aspect, which is computer hardware needs. Then after that, we shall look at software and computer network connectivity needs. In a modern industrial processing facility, such as food, chemical, or pharmaceutical plants, the integration of appropriate computer hardware is essential to ensure operational efficiency, real time monitoring, safety, and quality control. Various hardware components are required at different stages of the production, storage, administrative process, tailored to their specific roles within the facility. To begin with, the input devices in the plant serve as the frontline tools for collecting real-time data from the production environment. In drying and storage sections, temperature and humidity sensors are employed to monitor and maintain optimal environmental conditions. These sensors help in preserving the quality and stability of raw materials and final products. In areas where pasteurization or thermal treatment is required, thermocouples are strategically installed within the pasteurization units. These devices accurately measure and regulate heat levels, ensuring that products undergo consistent and effective thermal processing to meet health and safety standards. In evaporator systems, especially those operating under reduced pressure, pressure sensors play a vital role in monitoring vacuum conditions. Maintaining the right pressure is critical to controlling evaporation rates, energy efficiency, and final product quality. In the packaging and warehouse areas, barcode scanners are deployed to streamline inventory tracking, ensuring proper labeling and facilitate traceability throughout the supply chain. For instance, alarm systems are configured to alert personnel in event of fault, deviations from set parameters, or potentially unsafe conditions. These audible and visual alarms enable rapid response to critical situations, thus minimizing downtime and ensuring safety compliance. In the control room and on plant floor, screens and human machine interfaces (HMIs) are installed. These provide operators with real-time visual representation of the plant operations, allowing them to monitor, adjust, troubleshoot systems as necessary. Let's look at the software and network connectivity needs of the powdered milk company. To effectively support the advanced hardware infrastructure in a processing facility, a suite of specialized software and reliable network connectivity is essential. These software systems enable monitoring, control, planning, management across the various departments, ensuring the entire plant operates as a coordinated, efficient unit. Routine tasks such as reporting, document preparation, and internal communication are supported by Office productivity suites, including the word processors, spreadsheets, email clients, and presentation tools. These applications are essential for administrative work, communication among staff, and formal documentation required for audits or client reports. Given the rising threat of cyber attacks on industrial infrastructure, cybersecurity software is indispensable. These solutions protect the plant control systems, networks, and databases from unauthorized access, malware, and data breaches. Computer network connectivity. In terms of network and connectivity, the plant must be equipped with a robust, versatile infrastructure. Wired local area networks (LANs), typically using Ethernet, are employed in control systems and critical areas where speed, stability, and low latency are essential. In contrast, wireless connectivity for real-time communication among field devices such as sensors, actuators, and controllers. The Control Area Network Protocol is employed. CAN allows for fast and reliable exchange of data between devices in industrial automation systems, making it ideal for environments that demand precise and immediate control responses. Wired networks offer the high reliability required in control systems where any interruption could lead to process disruption or safety hazards. Wireless networks, while less stable, provide the necessary flexibility for mobile tasks in areas where fixed wiring could be impractical. CAN networks are critical in the plant automation framework, supporting real time control and data exchange with the speed and determinism that industrial systems need. This is the end of our presentation on the production of powdered milk. Thank you for watching to the end.